In 1a, we have the equation, the absolute value of 2x plus 3 is equal to 7. So this means that either 2x plus 3 is equal to 7, or 2x plus 3 is equal to minus 7. So we have two equations. We solve both. All right, first subtract 3 from both sides, and we have 2x is equal to 4. Now divide both sides by 2, and we have x is equal to 2. So that's one solution. All right, now let's solve the other equation. Subtract 3 from both sides, and we have 2x is equal to minus 7 minus 3. That's minus 10. And now divide both sides by 2, and we have x is equal to minus 10 divided by 2. That's minus 5. In 1b, we have 3x minus 2 less than 7. So that means that whatever's in absolute value is between 7 and minus 7. All right, so let's write that. So we have 3x minus 2 is between 7 and minus 7. And then we solve, first add 2 to 3 sides, all 3 sides. And we have 3x is between 9 and negative 5. And now divide by 3 on 3 sides. So we have x is between 3 on the right and minus 5/3 on the left. If the absolute value of something is greater than 7, that means that that something is either greater than 7 or less than minus 7. So that's how we open up these absolute values. We say that 5x plus 1 is greater than 7, or 5x plus 1 is less than minus 7. And then we solve. Okay, subtracting 1 from both sides, we have 5x is greater than 6, and divide by 5, x is greater than 6 over 5. And here subtract 1 from both sides, and we have 5x is less than minus 8. And divide both sides by 5, and we have x is less than minus 8 over 5. Okay, and put an or in between. In 1d, we have the absolute value of something equal to a negative number. Since an absolute value is always either greater than or equal to 0, it can never be equal to minus 10. So we just write no solution. One E has two inequalities with an or in between. Okay, so we just solve both inequalities. So we have on the left we have 2x less than, subtract 1 from both sides, so 7 minus 1, that's 6. And now divide by 2, and we have x less than 3. And on the right, just subtract 1 from both sides, and we have x greater than 9. And just put an or in between, and it's solved. In 2a, we have an expression raised to a fractional exponent equal to a number. So the way we solve this is we would raise both sides to the reciprocal of this exponent, which is 2/3. And we'll raise 8 to the 2/3 as well. Okay, and now when we multiply, we get 1 when we multiply these exponents. So we have 2x plus 1 is equal to 8 to the 2/3. All right, so first 8 to the 1/3 is 2, and 2 squared is 4. So 8 to the 2/3, that's 4. Let me just write that out. First we do 8 to the 1/3, that's 2. And now squared, that's 4. All right, now subtract 1 from both sides, so we have 2x is equal to 3, and divide by 2, x is equal to 3/2. Okay, now here we did, now notice that we raised both sides to the exponent 2/3, which is like taking a cube root of both sides. All right, so we don't do plus minus when we take a cube root of both sides, only when we take an even root of both sides. All right, like if there's a 2 in the denominator. But we did have a 2 in the exponent. Now that's the same as squaring both sides. All right, so whenever we square both sides, we have to check our answer. So we'll do a little check here. And substitute in 3/2 into the original equation. So we have 2 times 3/2 plus 1 to the 3/2 equal to 8. All right, so that's what we're checking. All right, these cancel. And here we have 3 plus 1, which is 4. 4 to the 3/2. We want to see, is that equal to 8? Well, 4 to the 1/2, that's the square root of 4, is 2. And 2 cubed is equal to 8. All right, so our answer checks. In 2b, we also have an expression to a fractional exponent equal to a number. So we start by raising both sides to the reciprocal. Okay, and here the reciprocal has an even number in the denominator, in fact 2 in the denominator. So that means we're taking the square root of both sides. And when we take the square root of both sides, in order to get both solutions, we take the plus minus square root of both sides in order to get the positive root and the negative root. All right, so whenever we raise both sides of an equation to a fraction, and if the denominator is even, we do plus minus. All right, so here the denominator is 2, so we do plus minus. Okay, so we get, well, by multiplying these exponents, we have 2x plus 1 to the 1 equal to, we'll do 9 to the 3/2. And then we have another equation, 2x plus 1 is equal to minus 9 to the 3/2. So here we have two equations. 9 to the 3/2, that's 9 to the 1/2, which is 3. In other words, the square root of 9, and then cubed. All right, so this is 3 cubed. So that's 27. So this breaks up into 2x plus 1 is equal to 27. And then we also have 2x plus 1 equal to minus 27. All right, now solve, and we have 2x is equal to 27 minus 1, that's 26. And x is equal to 13, that's one solution. And now subtract 1 from both sides here, and we have 2x is equal to minus 28. Divide both sides by 2, and x is equal to minus 14. All right, now here we did not square both sides. We took the square root of both sides. We cubed both sides. When we cube both sides, we really don't have to check our solutions. So we can assume that these are correct. In 3a, we have what's called a quadratic-like equation. So that's of the form something squared plus a coefficient times that same expression plus a constant coefficient equal to 0. If we replace 2x plus 1 by y, we'll have a quadratic equation. So let's do that. Let's write y equal to 2x plus 1. And then we have y squared plus 5y plus 6 equal to 0. And we'll solve this by factoring. Okay, so this is y plus 3 times y plus 2. Okay, check the middle term. 3y plus 2y is equal to 5y. All right, so we have y is equal to minus 3 and y is equal to minus 2. All right, now we want to know what x is equal to, so we have to substitute back. Okay, in other words, instead of y equal to minus 3, we write 2x plus 1 equal to minus 3, and 2x plus 1 equal to minus 2, and solve these two equations. So here I'm subtracting 1 from both sides on the left, and I have 2x is equal to minus 4. Divide by 2, x is equal to minus 2. So that's one solution. And here subtract 1 from both sides, and we have 2x is equal to minus 3, and divide both sides by 2, and we have x is equal to minus 3/2. In 3b, we have another quadratic-like equation. So that's something squared, and then we have a coefficient times that something, plus a constant equal to 0. So this is quadratic-like. And we'll do what we did in 3a. We'll write y equal to the expression 1 over x plus 1. And then we'll do our substituting, and we have y squared minus 3y plus 2 equal to 0. All right, so let's solve this quadratic equation by factoring. All right, and we have this factors as y minus 2 times y minus 1. Okay, and check the middle term, minus 2y plus minus y is equal to minus 3y. All right, so we have two solutions, y equal 2 and y equal 1. All right, and now we replace y by what it's equal to get the x solutions. So we have 1 over x plus 1 is equal to 2, and 1 over x plus 1 is equal to 1. Right here, let's say cross multiply, and we have 1 is equal to 2 times x plus 1. Okay, so that's 1 is equal to 2x plus 2. Subtract 2 from both sides, and we have 2x is equal to 1 minus 2, that's minus 1. And divide both sides by 2, and we have x is equal to minus 1/2. All right, here cross multiply again, and we have x plus 1 is equal to 1, and subtract 1 from both sides, and we have x equals 0. Now let's look back in the original equation. The original equation was a rational equation. That is, we had expressions with denominators. All right, and those denominators cannot be equal to 0. Okay, so if we have a solution of x equal minus 1, then we have to reject that solution, x equal minus 1. But we don't have that. We have x equal minus 1/2, and we have x equal to 0. So we say that both of these are valid solutions. Question 4a is a quadratic equation, because when we multiply through by x, we are going to get an x squared term. So the first thing we try is to solve this by putting it in standard form, that is setting it equal to 0 and factoring. So let's try that. So let's first start by multiplying through the parentheses. Okay, so we have 2x squared minus 5x equal to 3. And now standard form requires a 0 on the right-hand side. So let's subtract 3 from both sides, and now we have 2x squared minus 5x minus 3 equal to 0. Okay, so now the quadratic's in standard form. So now we're ready to factor. So let's do that. Let's try to factor. Let's see if this factors. All right, here we have 2x squared, so we'll break that up as 2x times x. And here we have a minus 3, so we're going to have 1 plus and 1 minus, or minus plus. Okay, we want to get minus 5x in the middle. So let's put a 3 here and a 1 here. All right, and this will be minus, this will be plus. Let's check the middle term. Here we have minus 6x plus x. That gives us the minus 5x in the middle. Okay, so this is the correct factorization. And now just set each factor equal to 0. Okay, here we have 2x plus 1 equal to 0. 2x is equal to minus 1, and x is equal to minus 1/2. So that's one solution. And x equal to 3. That's our other solution. In 4b, we have a polynomial that we want to solve, a 4th degree polynomial. So we'll try factoring, that is setting equal to 0 and then factoring. So first set equal to 0, subtract x squared from both sides. And now we can pull out an x squared, all right, to begin factoring. So there we have 4x squared minus 1 in parentheses. Now 4x squared minus 1, notice that's a difference of two squares, so that factors as a difference of two squares. That's 2x plus 1 times 2x minus 1. All right, let's set each factor equal to 0 to get our solution. So here we have x squared equal to 0, and when we solve that we get x equals 0. 2x plus 1 equal to 0. That's 2x is equal to minus 1, or x is equal to minus 1/2. And we have 2x minus 1 equal to 0. So that's 2x is equal to 1, or x is equal to 1/2. And those are our three solutions.